Welcome to my short lecture on the subject Smart Cities and Communities. Now we will be discussing the portion of the syllabus that is coming under unit number 4. So unit number 4 is all about the water resources, how we will be able to manage the water resources, and by including what infrastructure we will be able to achieve smart water management. All these things we will be discussing in this unit. And as you can see in the slide, under this we will be having storage and conveyance system of water, that is how water is actually stored in various forms and how it is being conveyed to the domestic premises. Then comes sustainable water and sanitation, that is the existing water resources, how we will be able to save them for the future generation, and how we will be able to achieve safe sanitation. Then comes the sewerage system, disposal of human waste, etc. Then what are the different ways in which you can do flood management, and how we will be able to conserve precious things like rainwater, etc. This will be including rainwater harvesting. These are the things that we'll be discussing under this unit, which will be a sub-portion of smart cities and community. Only by having all these things we will be able to call the city to be smart and the water management to be smart water management. Welcome to my short lecture on the subject Smart Cities and Communities. Today we will be discussing a topic on unit number 4. Unit number 4 is the management of water resources and related infrastructure. Under that we will be discussing now module number 1, that is storage and conveyance system of water. Water, as we all know, it may be non-potable or potable. Potable water we will be usually using for our consumption, for drinking, and non-potable water we will be majorly using it for agricultural purposes. So if you consider developing countries and some developed countries, for example in India is usually a tropical country, and it becomes very necessary to store the water for later use during dry season. For agricultural purposes, how will we be storing the water? That becomes the question. Water is stored for later use. You actually, in terms or in forms of natural water resources like groundwater, aquifers, soil water, natural wetlands, artificial ponds, tanks and reservoirs, and major dams. But for drinking water, for general water consumption, we will be storing the water in water towers or overhead water tanks. When it comes to conveyance, we have already seen how to store the water. Now, how to convey the water to the water distribution lines for our domestic service. So there are two stages in the transportation of water. From the storage point of view, the water should be conveyed to the treatment plant, that is the first stage. Then from the treatment plant, the water should be conveyed to the domestic supply lines, that is the second stage. So the first stage, water is transported by gravity or by pumping or by combined action of both, depending upon how the treatment plant and the sources of supply is elevated. Second stage, water transmission may be either by pumping into the water overhead tank and then supplying it by gravity, or by pumping the water directly into the water main for distribution. Now, the conveyance systems of water that acts under gravity are canals, flumes, grade aqueducts, grade tunnel, free flow system. Those acting under pressure are pressure aqueducts, pressure tunnel, pressure mains, inverted siphon. Now, then comes the means of serving water to the domestic lines. We in our households have pipelines with the help of which we are having a running water system. So pipes are nothing but circular closed conduit through which the water flows either under gravity or under pressure. But in sewer lines, as we can see, sewer lines, they just work under gravity. But the supply lines, they run under pressure. The selection of that pipe material depends upon several factors, especially the internal pressure, the external loads, and then the type of water that is carried by the pipelines, which leads to the corrosion, and the capital cost, maintenance cost, availability of funds, and the carrying capacity of the pipe. And when saying pipes, there are different types of pipes which are actually in common use, which are listed in the slide, like cast iron pipe, wrought iron pipe, steel pipe, RCC pipe, PSC pipe, and plastic pipe. So this is how we will be actually storing water and convey the same to the water supply lines. With this, we will close the session. Hello and welcome to my short lecture on the subject Smart Cities and Communities. Today we will be discussing module number 2 for unit number 4, that is sustainable water and sanitation. India actually is a country which is having limited space availability, that is limited land availability, and but the population keeps on growing. So the problem of access to safe drinking water and sanitation facilities in the urban areas of India is a major concern. And in India, almost 163 million people do not have access to safe drinking water, and 210 million people lack access to improved basic sanitation. And the wastewater that is let out by the growing population, it is not treated properly, as there are no waste treatment facilities in greater number. These problems can be overcome by adopting a smart water management systems, and this will lead to a more resilient and efficient water supply system, leading to reduction in costs and improvement in sustainability. So this smart water management system can be achieved by making use of high technology solutions in the form of digital meters and sensors, supervisory control and data acquisition system, and GIS. The World Commission on the Environment and Development has defined the term sustainable development as the development that meets the need of the present without compromising the ability of future generations to meet their own needs. In the case of water management, sustainability is divided into 3 main dimensions. Society-wise, it will be contributing to the quality of life of the citizens. Economy-wise, operation and maintenance of the water services will become cost efficient. Environment-wise, the ecological balance of natural water system is maintained by not abstracting or extracting more than can be replenished and preventing pollution and erosion. The targets or benchmarks for smart water supply are as listed here: 24 hours, 7 days supply of water to all the households. 100% household will be provided with the direct water supply connections. Per head, 135 liters of water supply, and 100% metering of water connection, 100% of efficiency in collection of water related charges supply, and all these is to be achieved as per the targets that are set by Smart Mission India. With this, we will close the session. Hello and welcome to my session on smart cities and communities. Now we will be discussing sanitation under unit number 4. Now, what is sanitation? Sanitation is nothing but the provision of facilities and services for the safe disposal of human urine and feces, and this disposal should be done in an economically viable, socially acceptable, technically and institutionally appropriate manner. And besides protecting environment and the natural resources should also be important. Sustainable sanitation has some certain principles. The first principle is to recognize that excreta and wastewater are not waste. If they are properly recycled, they could be reused and they could be made valuable. The main objective of such sanitation practices is to provide a healthy and clean environment and breaking the cycle of disease. But there are certain challenges in this urban sanitation. The first problem is rapid urbanization, fast settlement of people in the cities, and there is a strict need for a policy. Maintenance is inadequate, management is ineffective, groundwater contamination, over dependence on wastewater management, maintenance and upgradation of wastewater treatment facilities, necessity for capacity building of officials who are present in ULBs, etc. There are three major problems in following these sanitation practices. The first one is consumption of more water, more energy, unable to segregate feces and urine, problems with existing drainage system. So the first and the foremost thing that we are to do is to reduce the quantity of water that we are using in toilets. So in order to achieve this, we could go for improved designs of toilet systems. Present toilet sanitation needs 13 to 15 liters of water per flush. So a typical Indian house will be needing 60 to 90 liters of water. And this will require high electric powers, high amount of water, etc. So let us check out some improved toilet systems. A redesigned 5-liter toilet, a siphon system pipe is modeled with a spring. As feces, urine, water comes, the center of gravity moves to the left, causing the spring to bend downwards to allow easy exit. Thereby, it will lead to less use of water. Next comes a solar-powered self-cleaning toilet. It is made up of steel, and they are installed in places where access to electricity and common sanitation is difficult, and they are user friendly, and they are available through an Android app called eToilet, and they are also provided with some sensors for light and exhaust fan to ensure that they consume less power, minimum amount of water, and there is also provision of wastewater treatment using anaerobic biodegradation, which is an eco-friendly method. And in sanitation, we can also make use of IoTs, Internet of Things, and large premises where frequent footfalls happen, like in case of an educational institution or a railway station or a hospital or a bus station. Sanitation supervision personally will be difficult. In such a case, we can place odor sensors in toilets, getting sensors equipped with communication modules like WLAN. We will be able to get notifications by using a monitoring server or system whenever the odor intensifies, and then we can make a physical personal approach to solve the problem. And another innovative sanitation solution is by using a bi-slant conveyor belt toilet. And current toilets use single tank system, which results in mixing of urine and feces. Suppose if you are able to separate them, urine usually consists of a large amount of nutrition, like in case of phosphorus and nitrogen. So it will be a better option to separate these two. And this can be done by using a bi-slant conveyor belt toilet, which has two tanks, and there is a belt mechanism which carries and delivers feces to the back tank, and the urine slopes into the front urine tank. Apart from this, we may also have separate designs in which are innovative practices that by following all these innovative practices, we will be able to have a sustainable and smart sanitation system. With this, we will close the session. Hello and welcome to my short lecture on the subject Smart Cities and Communities. Now we will be discussing Module 3 and Unit 4, that is Sewerage System. In a smart city, all over the city, we should have proper sewer networks which will collect the sewage from its source of generation, and then the collected sewage should be treated using appropriate available economical technology to the prescribed disposal standards, and then only the treated sewage water should be safely disposed to the natural water bodies. For instance, let us take for example big industries like leather industries. In order to produce the garments, they make use of the normal water, and after using this water they will be unclean with chemicals involved, and hence they are to be properly treated, and then only they are to be disposed in natural water resources like rivers. In India, the estimated sewage generation from towns and cities, the towns and cities, they represent about 72% of the urban population, and the estimated sewage generation is about 38,524 million liters per day. But the treatment capacity exists only around 11.787 million liters per day, that is only 30%. And 35 major metropolitan areas, which usually has a population over 1 million, but the collective sewage treatment capacity is just over 50%. The challenges, as you see, only 5 metro cities with treatment capacity close to 100% exist. These cities are Hyderabad, Vadodara, Chennai, Ludhiana and Ahmedabad. Delhi has the largest sewage treatment capacity, but it meets the needs about 60% only, while Mumbai is the second one. It is placed in the second position, but its treatment capacity meets the needs only 80%. Almost all the other major metropolitan cities have treatment capacities below 50%. The main challenges may be on-site or off-site. On-site challenges is relevant, or it is related to the cost that is involved. The conventional engineered wastewater treatment system is extremely expensive, as it requires complex operations. Maintenance cost in expanding them is really a challenging one, and the capital cost that is involved in establishing collection and treatment systems is much more than the government plans to spend. So as a result, the progress in increasing coverage is likely to be slow in the foreseeable future. Off-site challenges includes macro factors like free trade agreement, cost sensitivity, climatic and usage considerations, and they directly impact the operations in India. And there are immense opportunities for foreign companies because they are having advanced viable technology. Why do you need to go for wastewater treatment? The main reason is given here. Wastewater as such, it will be consisting of organic, inorganic substances that are dissolved in them. That includes toxic elements like cadmium, zinc, copper, chromium, arsenic, mercury, lead, etc. So this sewer water, if they are directly disposed to the natural water bodies, they will lead to aquatic animal life death. And if this water without treatment is directly led to water bodies like rivers and oceans, and if this water is consumed, that will lead to health problems in a long run. And these health issues will in turn affect the GDP, and the ground and surface water sources will become polluted, and water supply will become costly and inadequate. So we should compulsorily go for sewerage systems, and this sewerage network can be a separate system or a combined system. If sewage networks are provided both for sewage and storm, then it is a combined system. If they are to be led separately, then it will be a separate system. With this, we will close the session.